Hello everyone from the world of industrial automation. My name is Artem Melnik and I'm a software engineer with 15 years of experience. I specialize in developing firmware and software for programmable logic controllers, as well as integrating the CODESYS runtime system into these firmwares. On this YouTube channel, I will be creating a prototype of an automated control system based on CODESYS. And together with the viewers, we will be bringing this prototype up to an industrial level. We will gradually work with you to identify and fix the shortcomings of this prototype, as well as integrate the solutions you suggest for the problems we encounter along the way. But the main goal of this channel is to teach how to work with CODESYS using real-world examples of automated control systems, not with a virtual PLC, but with an actual controller and other industrial equipment from the German company akYtec. But first, let's define the task. Let's develop an automated control system for an industrial dry heat sterilizer, which is used to disinfect metal instruments, for example in the medical field or the beauty industry. The standard sterilization temperature, both in Europe and the US, ranges from 160 to 180 degrees Celsius, with this temperature maintained for 60 to 90 minutes. Depending on the specific types of instruments and the recommendations of their manufacturers, this process destroys bacteria and viruses without damaging the instruments themselves. To control the temperature in the sterilizer, we'll start by using the simplest method, two-position control by turning the heater on and off with a relay of a remote output module. Now let's take a look at the graphical user interface that I created using the visualization editor built into the CODESYS environment. I'll demonstrate how the prototype works. I'll set the target temperature to 170 degrees and the holding time. I'll set it to 1 minute so we don't waste your time. In addition, you can set other parameters, for example the hysteresis, which is defined relative to the target temperature. There are two limits. When the upper limit is reached, the heater should turn off. When the lower limit is reached, it should turn on. Right now, we can see that the temperature sensor in the sterilizer is showing 25 degrees Celsius. Let's press the button and watch the process speed up. When the button is pressed, the sterilizer switches to the air heating phase, up to the required temperature. At the same time, if the safe temperature is exceeded, a warning light will turn on to alert us that there is a risk of burns if you try to take out the instruments right now. When the target temperature is reached, it is maintained for a set period of time. And while we wait for this process to finish, I'd like to add that not all controllers with the CODESYS environment come with a web visualization license. But the controller from the German company akYtec does include such a license. This means the user doesn't need to purchase it separately or go through additional, often complicated steps to activate it. Web visualization lets you control the automated system from any device with a browser, including your smartphone. With a bit of extra effort, you can even do this from anywhere in the world. After the holding time has elapsed, the sterilizer will switch to the air cooling phase. At the same time, once a temperature safe for humans is reached, the emergency lamp will turn off, indicating that it is now safe to remove the metal instruments. At that moment, the button indicator will also turn off. So we've defined the task. Let me show you how you can easily and quickly implement this prototype in the CODESYS environment using German equipment from akYtec. I've already prepared a sterilizer program project in advance, but I want to show you how to create a project from scratch. To do this, you need to click on the File button and select the New Project command. Note that in the window that appears, you not only have the option to choose a standard project, but also ready-made project templates for akYtec devices. In particular, here we see the SPC210 Touch programmable controller, which we will be using. This means that the manufacturer has pre-configured projects for each modification of their equipment. If we draw an analogy with other manufacturers, usually you would have to create a standard project and manually enter some typical settings each time. But with akYtec, this process is much simpler and you just need to select the required equipment modification. For example, these project templates already include visualization by default. With the correct screen resolution, some commonly used system libraries are already added, and, for example, global variables are linked to the nodes of the project tree. Now, let's declare the variables corresponding to the sterilizer settings. Some of them need to be retained even if the controller is powered off. To store them in non-volatile memory, we use the VAR retain area. I'll briefly comment on the purpose of each variable. The current number of switchings for each relay. We'll use the main relay and a backup relay. The type of relay being used. A value of 0 corresponds to the first relay, the main one. A value of 1 corresponds to the second relay, the backup. The mode for selecting the main relay. 0 means auto-switching. Switching to the second relay will occur after the first relay's lifespan is exhausted. 1 means the first relay is the main one. 2 means the second relay is the main one. The maximum number of relay switchings, that is, its lifespan. Target temperature for disinfection. Hysteresis value. Safe temperature at which instruments can be removed from the sterilizer. Time to maintain the target temperature in minutes. Now, about these variables, which we don't need to store in non-volatile memory. Their values will be generated in our program. Sterilizer status, 0 means off, 1 is heating, 2 is holding temperature, 3 is cooling. Sterilizer status has a string for visualization display. Start and stop button for the sterilization process, used in the visualization. Current temperature value. Timer for counting the holding time. Signal to turn the first relay on or off. Signal to turn the second relay on or off. Command for the heater simulator. Value 1 means heating, value 2 means cooling. Now let's take a look at the structural diagram of the equipment we'll be using to solve our task. As we already mentioned, a programmable controller SPC210 is used as the controller to which two input-output modules are connected via the Modbus TCP protocol. The analog input module MV210101 is used to connect a thermocouple that measures the temperature inside the sterilizer. And the two relay outputs of the 210 Malawi and HVAC 311 module are used to control the heater. All the devices mentioned are connected to each other through a router that has internet access. This will allow us to demonstrate the operation of web visualization, as well as connect the SPC210 controller to the akYtec cloud service. A real sterilizer is quite expensive equipment, so we will not use it. Instead, we'll replace it with an emulator, a simulator built on another SPC210 controller, to which a MU210502 analog output module will be connected. The analog output of this module will be connected to the analog input of the MV210101 module and will be used to simulate temperature changes in the sterilizer. Now let's set up polling of the mentioned modules using the Modbus TCP protocol. In my project, this is already configured, and it's done using templates. To add templates to the Modbus TCP master component, you need to right-click on it and use the Add Device command. You can use the manufacturer filter to see only the devices you're interested in. Let's add the template for the MV210101 module, the analog input module. This template, developed by akYtec, frees the user from needing to know what Modbus is. meaning you don't have to spend time studying documentation, the module's register map, or worry about how to properly configure a bunch of parameters to form requests, or rearrange registers to get correct data and convert them to the required types. In this template, all the data has already been processed, and all we need to do in the settings for the analog input for the first analog input is select the 4 to 20 milliampere measurement mode. Since we're not going to connect a real temperature sensor to this input, but rather the analog output of the MU210502 module from the heater simulator project, which I'll show in the next video. The simulator project is very useful for debugging our sterilizer project when there's still no industrial setup with an installed temperature sensor and heater. Let's set the upper limit to 200 degrees Celsius and the lower limit to 0. Next, let's link the variable where we'll receive the already scaled temperature value converted from milliamps to degrees Celsius according to the range we set. Range? Now let's add the template for the MK210311 digital input-output module. We'll link variables to its first and second relay outputs that correspond to the state of the first and second relays, which we'll use to turn the heater on or off. And this whole process takes us less than a minute thanks to the ready-made template developed by akYtec. Now let's go to the visualization editor and set up the graphical elements. Variables from our program are linked to them through the text variable parameter. In addition, other settings are configured. For example, for elements that display certain values, you need to specify the input-output specifier and, if necessary, an explanatory text. For example, for floating point variables, this kind of specifier is used. Also, for the necessary elements, press handling is configured, for instance, for entering new values and so on. We'll tell you all about this in one of our upcoming videos. Now, let's pass some of the variables up to the top level of the automation system, for example, to the cloud service of the German company akYtec. To do this, you'll need to add the symbol configuration component to the CODESYS project and check the boxes for the variables you want to export to the cloud service. For each of them, you can specify the access type, read and write, or read only. Pay attention to the akYtec cloud component. In the project tree, you can set a password for it, which will be used to encrypt the transmitted data. Let's remember it. Now let's go to the web browser, open the akYtec cloud service, and add a new device. Let's select the device type, Programmable Controller, SPC210, and for the addition method, choose Auto Detection. We'll also need to enter its serial number, which you can find in the controller's web configurator. Click Add. We also need to enter a name for the device. Now we need to set the same password that we just saw in the akYtec cloud component. After a short while following the addition, the cloud service will automatically upload all variables from the controller that are marked in the symbol configuration. Notice that instead of the variable name, the comments are displayed, which is also very convenient. Now, let's take a look at the real process chart of the sterilizer in operation. We can see that it displays all three phases we mentioned: heating, holding, during which the chart takes on the characteristic sawtooth shape of two-position control, and cooling. It should be noted that even with a minimum polling period of 60 seconds, which is available on the free akYtec Cloud plan, you can see that the sterilizer operates in normal mode without any deviations in its operation. When you purchase any device from akYtec, The cloud service is completely free, although the free plan, as already mentioned, limits the minimum polling period and some other features. But for our prototype, this is not critical at the moment. In the next video, we will take a detailed look at the sterilizer's algorithm code in ST language and review all the visualization components of our prototype. Now, I invite you to point out any shortcomings you've noticed and suggest ways to address them. We're also looking forward to your suggestions for improving the sterilizer's algorithm. For example, you might suggest replacing the current temperature control method with a more precise one, such as PID control. Additionally, I'm offering you a choice of the following topics for upcoming tutorial videos, which I've pinned on the channel. How can you use the built-in OPC UA server in CODESYS to integrate SPC210 into popular automation platforms from well-known companies? How can you use the built-in cybersecurity tools in SAP 210 to protect against hacker attacks? How can you increase the speed in CODESYS of response for SPC210 and the input-output modules pulled via the Modbus TCP and Modbus RU protocols? What are the advantages and disadvantages of the Modbus master and slave modes of Weintek operator panels when used together with SPC210? What are the advantages and disadvantages of multitasking in CODESYS? How can you use the visualization editor in CODESYS to create a multilingual project and set up screen navigation? How can you use the built-in Linux utility call library in CODESYS to integrate SPC210 with popular automation platforms from well-known companies or with any specialized applications? How can you use the built-in akYtec communication library in CODESYS to bypass the limitations of standard Modbus components? Let us know in the comments which of these topics interest you most, or suggest your own. And also, if you want to learn CODESYS using real industrial equipment, our channel has the exclusive right to provide a promo code. For a 35% discount on the purchase of SPC210 and I/O modules from akYtec. To get this promo code, just follow the link below to our WhatsApp or Telegram channel, and in the channel profile, you'll find my personal contact where you can send a direct message with the promo code. But I want to point out that this promo code is only valid for 24 hours. So please write only if you have already added the products to your cart on the akYtec website. And here's another nice surprise for those viewers who purchase the SPC210 and send me the serial number of their controller in a private message. I will provide all the CODESYS projects used in our channel's videos for free. You can also subscribe to our WhatsApp and Telegram channels so you don't miss announcements about upcoming videos. And of course, so you can always get a promo code for a discount on akYtec products. And don't forget to subscribe to our YouTube channel so you don't miss our next videos, and give this video a like if you enjoyed it. That's all for now. See you in the next videos.